Well, my ancient Weller soldering station finally died, and I think it's got to the point where it's not really economical to fix. We'll talk more about that in a minute. So I bought one of these kits off of eBay that has the handpiece and the control board, and they give you a tip to start out with. And this costs about, well, $28, $30. Well, it also turns out that in order to fix this thing, the old guy here, I have to replace this heater with a newer version. They don't make this anymore. In order to accommodate the newer version, I have to change this shroud piece. So that's about, I don't know, 30 bucks there. And there's a big difference in the tips. These guys use a tip that has a metal cap on the back of it, and this is an alloy, a magnetic alloy. So when the Curie point is reached at 600 degrees, it becomes non-magnetic, and that's how they control the things. So you have to pick a tip, you have to pick the style, and you have to pick the temperature you want. And this center barrel has got a switch in it and a magnet. So when this becomes hot enough to go over the Curie point and become non-magnetic, the reed switch that's down in here opens up because the magnetic circuit is broken. And I don't think you can hear it, but I can hear the switch flipping when you do that. So these tips, these T12s, and one of the reasons they're popular, include the heater and the sensor. So you've got, three connections here, the outside and these two bands, all in one tip. So when you replace this guy, you get fresh everything, and you really can't beat that. This right here is a pack of 10 I also bought off of eBay of the supposedly, brand name parts. Don't know if they really are. And I just picked a pack of 10 that didn't have one of these blades in it. And these worked out to be about $3 a piece, which is a heck of a deal. Now, if you buy them individually, especially from the electronic supply place, you're going to pay a lot more for them. But even then, you can pick up the more popular versions of this for $5 on short notice. And these tips, if I remember the last time I bought them, they were closer to like $10 a piece. But of course, this kit doesn't come with a power supply. You have to provide your own power supply, and there's actually some supplies and some boxes they also sell if you want to do this all yourself. Or, yes, of course, I could spend $70, maybe as little as $50, and get a really basic soldering station from out of China that uses these T12 tips. But what's the fun in that? I want to make something custom. So what we're going to do is reuse this as the power supply, because I know this thing is 24 volts. Now it is 24 volts AC, so I have to add a bridge rectifier in here and a bulking capacitor. I don't think I'll have to add any regulation. I don't think. I may have to put a bleeder resistor on it, because I really don't want to go much over that 24 volts when it's off, just to be on the safe side. So that means I'll have to do a little work on the front of this, measure this guy out, and do some layout and cut a window, drill a hole. And you can put this on the board, the connector, but I'm going to take this connector off and mount it down here. So I'll use these little wires, and I guess that's why they came in the board, to jumper between the two and reuse this hole. So let's run through the bits and pieces down here of the kit right quick. This is a circuit board. It obviously, there's an encoder here that's got a push button click function, because you can do some setup on it. Calibration, if you really need it tight and you have one of those tip measuring temperature things, you can set that. On the back, there's one of these like only seen in China type micros. I don't know, well, it might be something I'm familiar with, but the number is completely weird. I tried to look it up, but it's China only type parts. And This is your power lead, plus minus, and a frame ground that goes all the way through to the tip. So you need to put this on your third wire on your power cord. And a knob and an idiot light that goes in here. I'll have to make a little opening for that. It comes on when the tip is hot. Well, not when the tip is hot, but when the tip is powered. And let's take a quick look at how this soldering iron handle goes together. Now you want to wire these things in a standard way so this handle can be plugged into like a standard T12 compliant type power supply and not damage anything. And also you want the one we're going to build to take a pre-made handle, you know, if down the road we have more than one handle, and sometimes you'll do that, you just leave a tip in one. So inside of the barrel there's this nifty little circuit board skeleton with contacts on it that the tip mates into, and it has a place right here for a vibration switch. Yeah, a vibration switch. That's what this, I wound up with two of them somehow, but that's what this is. And you can feel something moving inside of this thing, and that solders in right there. And what that does, it lets the brain board here sense that you've picked the soldering iron up, or the soldering iron has been resting for a while, and it will drop the temperature. And that really saves the tips, makes them last much, much longer than these guys, which these are like, you know, burning all the time. So you have 5 holes here, and strip this back, solder it in, and tie it off. They even give you a tie wrap. Tie it off to this little arm right here, and then you feed the whole deal, the cable down in there, and then put this on. So it goes on like that. Cap goes in, and the tip goes in, and the ferrule and the nut go on. And then you flip your power back on, and you're up and running in just a couple minutes. These things do heat really fast, which is kind of nice because because this nut is so far back and this ferrule is so short compared to this guy. If you do it quick, you can usually just knock that off, pull this out, and drop it in a holder. The holder that goes with this actually has a place to put tips, and grab another one. Say you're changing from a heavy operation to a fine operation, drop this down in there, slip the thing over the top, screw it on, flip the power back on, in a minute and a half you're back up and running. One thing I do like about this, reusing this, is I've already got a power switch on here, which will make life a lot easier. Just turning this thing off, because it really doesn't have its own power switch on here. And cord and everything, you know, handy. And it also has a matching, I don't have it out here, it also has a matching holder and sponge tray that clips on the side that the new handpiece will go in. So the next thing we need to do is to open this puppy up and make sure there's no surprises. Okay, let's gut this thing like a fish. These things gonna come out here? No. Alright, let's persuade them another way. I'm assuming the feet. Oh yeah, okay. Yep, that's where the screws are. I have not pre-explored this. I was tempted to. So nah. Let me do it live. Well, sort of live. I think it comes apart right around there, and I'm hoping this front panel is just captive in there. It's small screwdriver work yet. See, this thing has got these slide lock holes on the side. You can put soldering iron holder on either side, which is handy for me since I'm left-handed. I always have my primary soldering station on my left, but I'm almost ambidextrous, so I can really go either way. It's really handy because I have been in the biz since before surface mount components were a thing, and right off the bat I started taking 2 soldering irons and flipping those guys off. And by the way, this thing has got a nice 3-wire cord on it, and if you guys do this with some other power supply, remember you have to run that ground so that it goes all the way through the circuit board to the tip. Ooh, that was easy. I've cleaned this thing up because it was in a smoking environment for God knows how long, and I sanded it, and I need to work on this edge around here too. Oh, nice little transformer we got there. And we have a fuse, and it looks like a hash capacitor. I reckon that's what that is. I guess that's to kill the sparks, the arcs, when it the switch that's up in here opens and closes. This is one of those winged type connectors, so that wouldn't be too hard to get out of there. And so the power cord just goes right straight up to this connector, excuse me, to the connectors on the back of the switch, and it has an extra terminal for the idiot light inside the switch, and there's your ground going through. So there's my ground, and I will, this thin box here might be a bit of a problem. I don't know if I'm going to run into that. No, I guess not. I don't think so. So I can leave that intact. So I am going to, let's see, let's untie this knot right here a bit. There we go. Alright, I may refer back to this video later as to where these wires actually go. So yeah, this is the line for the light. The white one is this is the idiot light in the switch connector here, and this is actually the switch on this side, because the hot comes up and goes through here and out the gray and over to the transformer. Pretty straightforward. And you notice they have this fuse in the line going, well, in the secondary. I don't know whether I'll leave that there. I'll have to have me think about that. It says use a 3 amp rated fuse only. I might have to leave that in there. I'll have to think about it. Alright, so I need to release this front panel so I can take it to the bench, and then I will also need to measure the voltage of this transformer. I might as well just disconnect it here. Don't think we'll be reusing those. Maybe not. Don't think I'll need this capacitor. rough on the fingers. Underneath that's free. What is that? And it's a 0.1. See, would it make any sense to put that back in there? Probably not. It's going to have a, it's going to go right into a rectifier. Set this rig aside. I might reuse it. And should I just I'll just disconnect it here and not pull. It's a lot easier to do that than pull off those crimps, well, those spade terminals. Yep, I just did a dum-dum. Yeah, hold the phone here. I want to measure the AC voltage so I can see whether I have to do anything special here to keep from frying my circuit board. Alrighty. Well, let me go get the meter right quick and plug this guy in. Off. I'll plug this guy in over here to the side. Will it reach? Will it reach? Will it reach? Yes, it will. Make sure we're hot. Yep, right back. I've got my connector on the board, and I skipped using the wire that came with it because it was just too darn huge and too darn stiff, and these terminals were just too small. So I used some hookup wire that's the same size, exactly the same size as the input wire, so yeah, that's fine. And this is going to let me move this connector down here. And I have my soldering iron put together. Ta-da! And I'll put up a schematic at some point, maybe at the end, of what this should look like inside and how this wires up. I'm going to take the photographs, the kind of crappy photographs that the manufacturer has, and drop a little pictorial type schematic and stick that up in the video so you'll be able to screen grab that. Alright, on to, almost forgot. Hold on. This is the connector out of the front of the panel here, and boy, that thing didn't want to come out. Obviously they have some special tool for taking these out, which I don't have. So this guy, this hole is, way too big. So what I'm going to do, at least I'm going to try to do this because this connector is otherwise useless. I'm going to take a thin saw and I'm going to cut right through there. I'm basically going to cut this whole front off of this connector, leaving this part that sits on the panel and the step here in it, and then I'm going to, let me grab that thing again, and that will put this here. Of course, this deep guard ring or whatever it is will be gone, and I'll just basically turn this into a bushing. I will have to saw down close to this barrel or right through this barrel on either side, and then cut this barrel out, and that should, according to my calibrated eyeball, that should let that nut sit right between these two wings, and I can still retain these wings to hold it in the hole, and I don't want to do anything like glue it in. So I think that will give me a nice looking bushing that already fits. Throw that aside, and let's get back to the problem we discovered earlier. Was the transformers got too much voltage. So I don't want to add, I've given this a lot of thought over the last day, and I don't want to add any more passive components, it just gets kind of silly to try to string a bunch of diodes in series to drop that voltage. I mean, I think we're going up maybe with 3 amps or something like that, so that would be a huge zener to put in series, and it just doesn't make a lot of sense to do that. So what I'm going to do, and I've already done a preliminary investigation here, is I'm going to strip turns off of the transformer. So this side is the start winding. It goes down the side and into the center, and this is the end winding, and this is the one that I'm going to unwind. So I'm going to take this wire off of it, this stranded wire off of it, and back those off. But I've got to figure out roughly how many turns to take off, so I can just estimate the number of turns across, and then I can look in this little slot right here and see how many turns are stacked up, you know, get a rough guess of it, and then figure out, you know, I've got to go from an RMS voltage of, I think it was 28, but we're going to measure that again here to be sure, down to no more than 18, probably closer to 17. And so when the iron is off, or when you just preliminarily turn it on before it starts heating, so any moment when it's not pulling current, the current will rise, excuse me, the voltage will rise up to the peak voltage, which can't be more than 24 volts. So conveniently, I've got some 25 volt caps around that are pretty good size for the bulk capacitor, and so we got to figure out how much I have to go off there. So if I've got to go from 28 down to 18, what is that, like around 40% off of the, that's quite a lot. We're going to reduce the current available from nearly 75 watts down to probably 35 or 40. I've got a chart that the manufacturer of this board had on their website, so I'll put that up for a moment and talk over it. So you see where the maximum available is, I think, I'm not looking at it right now, is like 75, but when it's on, if it drops down to 17, that's somewhere in the 35 to 40 watt range. Well, that's a plenty for what I'm going to do with it, because on an iron this size, I don't use the huge size tips anyway, and that will be fine. And this thing is actually rated to run as low as 12 volts. You can see what the wattage is on the chart for that. So I think we'll be good, and I won't have to add any fancy regulator. I'll just let it float up when the power MOSFET isn't sending any juice to the heater in the tip. So we need to remeasure this voltage. I want to make a note of it before I dig into this thing. And so I've got to pull all of this layers of tape off and then unwind. So let's jury rig this thing up right quick. And plug it into the outlet strip here at the bench, my temporary bench, I might say, so let's not get carried away. So let's scooch this over here, and I'm sure you guys love seeing the top of my head. And, just put this together. I'm kind of surprised about putting these wire nuts inside a machine enclosure. That's generally considered a no-no these days. But you see it a lot. Okay, now that's hooked up, and these are good. Alright, fire in the hole. It blinked the fluorescent light. And get the oldie but goodie meter in here. This thing was some of the best money I ever spent. 200 AC volts. Woo! Look out. See, I'm not adhering to proper discipline there. You always put this thing back on, you know, volt ohms. You always move these over on any meter when you get done measuring current. But yesterday I had to work on something for the wife. I might make a video about that later. And let's see what we got here. 27.7 volts. 27.7 volts. Okie dokie. So, knowing that, let me unplug this so I don't make one of those kind of YouTube videos. So knowing I got 27.7 there, and I need something under 18, maybe closer to 17. I'm going to run the numbers again. Let me sit down at the bench over here with this thing and calculate, and then start backing turns off and experimenting basically until I get it there. Well, after a couple of weeks of being out of the weather, I finally got back on this thing. Haven't been feeling too hot. Okay, I got the turns off of the transformer, and you can see I just simply put a tie wrap around there to strap it down and soldered the original wire back on it. Took quite a few turns off of it. I think it worked out to be about, I'm guessing with my estimate, about 180 total, and I think I took off about 40. That's what I took off right there. Quite a chunk of wire. Sometimes this wire is a little hard to come by, so I'm of course going to save it and wind a toroid with it or something later on. And I also got this connector cut out and made a bushing out of it. Now that was a real pain in the butt. And if you were to find a washer this thing fits in and just super glue the washer in the back, you're going to get no complaints from me, because that was a pain. I would suggest, if you try this, that you drill the center out first while you've got plenty of material out here to hold it with, maybe in a small vise or even your fingers. And once the center hole is drilled out and all the pins are pulled out, then cut the outside. And I used a Dremel and a knife and even an old soldering iron to do some good old-fashioned melting. That's a pretty tough piece of nylon, really. And I smoothed off, it's pretty smooth here around it. I smoothed that off by just turning up my sander and just holding it down on there until it's all the knife cuts and the scrapes and the saw marks were gone. So the next thing is I got to lay out on here, and using blue tape to lay out on is always a really good idea. I've got it laid out pretty square, and this piece of tape is a telltale. I laid it right down next to that divider and then rolled it up over the top so I get a good reference as to where that face of that wall is right there. And then I can put a my machinist square on here and scribe me a line so I know where that wall is. And then take good old calipers here. These things have gotten so cheap nowadays, and they're actually very good. A while back I compared a set, and it was a cheaper set than I got than these from Harbor Freight to the standards over to community college, and it was right on the money. So I'm going to go from the center, and I'm going to partly do this by eyeball. Go from the center and find the outer edge of this board, like so, and then get on this line and measure that out, and then go, well, you know, roughly the middle, and make me a crosshair there, and then drill it out to fit this connector. So I'm going to do this in steps, so, you know, I mean, I got one shot. I don't want to mess this thing up. Yeah, I could measure it out and draw it out and lay it out and, you know, and all that, but this is a one-shot deal, so it's not really a whole lot of point in that. And once I get that hole there, making sure that, you know, as I go, always drill it undersize and then work up to the size, because I might have to shift it a little bit, that I don't butt too hard up against this, just touch it lightly. And once I get the hole in there, then I'm kind of home free, because I can then stick it through this way, get it square, and mark the extents, the left and right side of this display on my tape. And if I measure the thing out and I find out that the control, and just eyeballing it, looks like it is symmetrical, then I can do the same trick with the top and the bottom. If not, I've got to, you know, figure out where this edge and this edge is in relationship to the center line of the pot, and actually plot that out on here. So either way, it's a little bit easier just to, you know, get what references you can off of your hole that you've made, and then the next step would be, you know, finding the top and the bottom. And I swear it looks, what do y'all think? It looks symmetrical. So if this is dead in the center, and you know, there is a crude drawing of this thing that the manufacturer provides, so maybe I'll look at that and see if this pot is centered up. Anyway, I do believe one other thing, that I'm going to put this 3-amp fuse back in series in the secondary like it originally was, because I'm definitely, especially after I drop the voltage, going to be pulling less than 3 amps. So that, I think, would be a good idea to put that back in there. And this is too much fuse for this side, and I'm not sure that you really need a fuse in this side. Maybe modern equipment probably would have a fuse in that side, and I'll look around. Maybe I've got a fuse holder somewhere. There's probably room for one on the back here. I don't know. Anyway, that's where I am so far. I will do another installment when I'm further along. Well, I've got it a little bit further along now. I cut out a hole in this plastic, drilled it, and then used the old nibbling tool. It came out pretty nice, but I mean, it's no thing of beauty. And I had a scrap of glass laying around, so I cut this little piece of glass to go over there, and this tape around there is that double stick 3M super sticky stuff like you mount trim on cars with these days. And I thought about putting it on the other side, but I didn't have enough room, because I've got this board backed off as much as I can with the washer. I just don't have enough distance on this threads on this control that's holding the whole thing in. Well, I guess it's okay. I can live with this. It certainly is substantial. It's a tough piece of glass that came off the bed of a flatbed scanner. I don't know later on if I find a nice piece of smoked plastic. I have enough room to put a fairly thin piece of plastic in here. I might do that. I can get this off. It's a little bit of hassle. If nothing else, I can run a guitar string under there and rub my way through that tape so you can get it off. But anyway, it's serviceable, and if I had to guess, it's probably going to stay just like that. I'm going to leave it alone. So now I need to put these wires in here and then hook my other cable, the supply cable, which I don't have laying over here, to this, and do my little board. I'm going to hang right on this screw. I should have brought those parts over here. I'm going to hang on this screw with a rectifier and just one big filter cap and maybe a bleeding resistor. So I'm going to go make that next, and then see, not too bad, huh? So when I make that board to go here with the rectifier and all on it, I'll be back, and we may be able to do a preliminary test on this puppy. We'll see. Okay, I got my rectifier board built, and I've got this finished. I say finished because I forgot to put in the little idiot light that comes on when you well, when it turns the heater on, it blinks this light. That's a good idea because you know when it's getting up to temp, and if this thing is staying on and it's getting cooler, well, you've got failure. And I've got my little wire bundle hooked here where, I believe I mentioned this before, but this connector will actually go on the board there, but I didn't want to put it way up here. I wanted to put it in the stock location, so I've got these few little wires run over there. And let me get on to the power supply side. So this is just a bridge rectifier with a big bulking capacitor on it, and you can see the bridge rectifier hiding right back there. It's one I ripped out of an old PC power supply. I think that cap came out of it too, and the cap is 25 volts at 2200, and a 1K bleeder resistor up here that helps stabilize the voltage a little bit. It actually pulls it from 25 down to almost 24, so that's good. And you see I did save the 3 amp fuse, figured to be good protection in case anything ever shorts upstream. In retrospect, I should have probably put it in the AC line, but I didn't do it, and well, I'm not going to change it now. So I see I've got my little wiring harness that came with the board hooked on to the plus and minus, and it's hooked to the ground. This ground line goes all the way to the tip, and I got my ground lugs over here on the transformer. So now we got to wire all this up. And one thing you always wonder is, particularly when you have a 3-prong plug, about half the time I forget which one of these is actually the line 1 and which one is the neutral. And you know, you do get outlets that are wired wrong. And if this was a 2-prong, sometimes those have a polarization tangs on them here that will only let them go in, you know, wide slot one way. So I'm going to plug this in and quickly show how to figure out which wire is which. One side of this is smooth and one side of this is ribbed. This is just an exercise. I already know which one is which, but it might be useful to someone to know how to do this. So I'm on AC volts now, yeah, and I'm not plugged into current. So I go between the 2 wires, and big stoopy, wrong way. And there's your 120, and then I go to ground, and then I check each one of these. Nothing there. 120 there. So we know this is the high side, the L1 side, and this is your neutral, and that happens to be the smooth side. Alright. Unplug it now so I don't zap myself and make an amusing YouTube video. So the switch has got 3 wires on it, and it has a neutral line because it has an idiot light inside of it. So we got to hook that to the neutral side, and if I remember correctly, yeah, the black is the in, or the line, and the gray is the feeder to the circuit beyond. If you get those mixed up, the light won't work right. Okay, where's my caps? Alrighty, I need the smooth side to the in. Having the neutral and the line backwards in this particular instance isn't a huge deal because we're all transformer isolated, but it's always a good habit to you know, put things the right way around. And then I've got 3 wires that have to go together here. So this is the neutral side of the power cord. So I need the neutral side of the transformer and the light wire together here. These little guys, these little wire things came in it, so I'm just reusing them. What the heck. Alrighty, and then this goes in a power hole over here. I'm going to put my finger behind this board because it's only suspended in here by the shaft of the control, so I don't want to hold this and shove it and break something. You can make a board intermittent by breaking a solder joint here and there. And this goes in. It was a pretty close fit when I sized this up originally, but I got enough clearance. It fits in there pretty neatly. Okay. See, all of this will just squish down when I put the cover on it. Alrighty, make sure the thing is off, and let's plug it in. And don't be surprised if the fluorescent light doesn't blink when I drop all this inductive on the same outlet it's plugged into. Hey, it did. Yay, it's coming on. See, the idiot light here for the line power is on, which means I got those wires the right way around. And that's reading 500 because it's not plugged in. And it knows that it has no sensor. You see, it's not trying to power it. Let's kill that. And reach back here and get the soldering iron part. I bench tested the board and the soldering iron together earlier just to be on the safe side. And I put this in my stand. This is a stand that locks onto the side of this because I don't want a hot soldering iron laying around and messing up my nice conductive work pad here. And contact. Now, watch how quick that thing heats up. These tips are very low mass, but you know, they have electronic feedback on them, so they can maintain their temperature. They're so much nicer to use than the older stuff that had that electromechanical temperature control. See, it's already pulse width modulating the thing. And bingo, we're up to temperature already. That's why it's so nice to be able to have your extra tips for different operations in here and just, you know, switch them out, flick it back on, and it's right back where you want it. That is cool. Now, or should I say, that is hot. Haha. So now I am curious as to what our voltage is actually running now. Let me scooch it down here a little bit. So let's go around to DC volts over here. I'm going to put it on. This thing has 220, 200 or 20, so you hit to pick one and see what it's running. Okay, it's blinking off and on. I mean, it's power cycling. What is that? Maybe 30% duty cycle, I guess. And, you know, considering how slow the meter updates, that's pretty good. That's not bad. It's not bad at all. That actually puts the power output a lot higher than I thought it would be, because we're only bouncing around a volt or two below the thing's maximum rating. So, success. Okay, what's the next thing to do? Okay, let's see, put the cover back on, put the feed back in, and then I'll go over all the ways you can set this thing up. It has a setup function. You hold a button in here and do something, and a code will come up, and it has a whole plethora of settings, like over a dozen ways you can set the thing up in the background. And I'm going to have to go print off the sheet, which I found and turned into a text document, and then I'll put that up later. And so I can run through these things, because, you know, I can't remember all of them. So I'll be back after I print that puppy off. Well, here we are at the end. I've used this guy a couple of days now on a few small jobs, and I must say I'm really happy the way it turned out. It was quite a trek, and some of you guys might go, well, it's just not worth the effort, but I thought you'd come out with something pretty cool, and you kind of got bragging rights when your buddies come over and you go, hey, look at this, man, and they go, wait a minute, that's not the old Weller soldering stations that I remember. So we have left to do, one of the things we have left to do is to go over the setup functions quickly here, and there's quite a few of these that you really won't ever have to mess with, like thermocouple, data, operational amplifier offset voltage, and amplifier gain, and all of that mess. That's something you really should probably never touch. It even has down here what appears to be, now translating, from Chinese to English, you get Chinglish and then trying to transfer that back to English where you can understand it. It appears that one of the setups here, number 7, compensates for the room temperature. Well, that defaults at 20 degrees C, so that's good for most, everything. And, if the room's like 5 degrees higher, it's not going to be that big of a deal anyway. So the big deals you have to deal with here is the very first setup is 00, and that's how you reset all these other parameters. So if you get in here and you get it messed up, you simply go to P00 and pick 1 and click it, and it defaults everything back to stock. And number 4 is how many steps to do with each step of the encoder knob. Well, this one is set on 10. I think that's okay for most purposes. I mean, you can turn it all the way down to 1. It's either 10, 5, 2, or 1, and that doesn't really make a lot of sense to put it on like 2 or 1. You can even put it on 0, which locks it down at whatever the last temperature setting was. I guess in a production environment that might be okay, where you're doing the same thing over and over again, and you want to make sure that you never accidentally mess up the temperature setting. And 5 is how long of wait time before it goes into sleep. And 6 is how long it waits before it shuts down, and that can be up to 180 minutes. The sleep time can be up to an hour, which I find is a bit excessive. I think I have these set at 10 and 30, and while I was working over there, it seemed to be okay. And if I got busy and it cut off, this thing reheats so quick it doesn't really matter. I just flip off and flip it back on, and boop, give me count to 10, and you're right back where you started. Now it has some other stuff down here that it appears it has a temporary temperature increase thing where you can do something with the knob. I'm not exactly sure what. Maybe double click it, and it will jump up to a preset temperature and then time out after so long. I don't really see how that is all that useful when you can just go like that, and it gets there like boom, and you can just wait a few seconds more and just to make sure it's there. So I don't see how useful that is. So there's actually 12 settings altogether. So those are the biggest one. How to reset the defaults, the temperature timeout, and the sleep timeout. The way it figures out the sleep is if you don't touch the handle, the vibration switch in here doesn't send any makes to the processor. So if you listen, I think you can probably hear that click in the handle. That's the switch clicking. It's like a tilt switch in a pinball machine, if I could make an analogy. And that's what wakes it up. And here's how you get to the menu. You give this a couple of second click, and it comes up with P, and that's P0, and then I don't want to change that, and then 1, 2, 3, 4. That's set for 10 minutes, and then 5 is set for 10 minutes? What? No, let's not do that. Let's set that for half an hour. Thought I had that set for half an hour. And then 6 is the Shutdown time. Oh, okay, I did have it set for half an hour. Duh. Okay, I'll fix that later. Um, and so on. The rest of the modes you're really not going to mess with, so I'll just stop right there. I will put this text file and my drawing and even the PDFs that the Quicko distributor puts out that are kind of iffy, but you can build it by them. I mean, it's basically a some photographs of parts that someone marked up in Microsoft Draw or something like that. I don't know. But I'll put all those up, probably give a link in the description down below, and put them in my Google folder and share them publicly. At the end of the video, I'm also going to, run them by as stills. So if you want to take a quick look at them, you can look at them that way. So this has been a fun project. I hope you all enjoyed it. I hope you all try this. And I reckon we'll see you next time. Well, it turns out it was not okay, and I couldn't live with it. As you can see, the glass is gone. Came off pretty easily. I put a couple of scratches in it, but that's all right. And it occurred to me that the easiest place to get some thin plastic is CD cases that we all have lying around. So I grabbed one of those and cut it up. Made me a little rectangle about the yay big, slipped it in behind and tacked it in place with a few drops of super glue. So now this is protected. I can't do something like maybe drop a little tiny ball of solder in it or something like that, and it keeps the dust from going down in here. Well, it still does have vents up here. So I thought I would add this in at the end just to show that, well, I was wrong. I couldn't have stunned it. Thanks for watching, guys, and remember to like and subscribe, and we'll see you next time. Next time I come up with some crazy project or something breaks. Bye.